Okay, so in this question they give you the derivative. What are you trying to find? What are you trying to find? They gave you the derivative. What are you trying to find? What's your end goal?
Oh, I know how to do it now.
What? You're going to integrate it, but what are you trying to find?
The original function.
The original function. You're looking for the original function. So you know that f prime of x is equal to 2 over 1 plus x squared, and it also tells you this initial condition right here. Nice. How do you go about integrating this? You're finding the general antiderivative. How do you go about finding the general antiderivative of this? Did anybody figure it out? Okay. Okay, I will.
1 plus x squared to the negative first power. Or you don't really know that.
It's hard. I mean, so you might be tempted to do this, right? 1 plus x to the negative first power. And what did I tell you? That x squared. Sorry, yes, that's very important. Now, what does that kind of look like, Biggie? It kind of looks like this, right? And you know that what's the general antiderivative of x to the negative 1? ln x plus what? Plus c. Is that correct?
Yeah.
So what might you guess the general antiderivative of this is? What might you guess? 2 ln of
1 plus x squared plus c.
Plus c, like this, right?
Is that not it?
Well, hold on. Let's check it, though. If that is the general antiderivative, what should we get when we take the derivative of that? We should get that, right?
Yeah.
Hold on.
Oh, I know.
Listen, hold on. If that is the general antiderivative, what happens when we take the derivative of this? We should get that, right? What happens if we take the derivative of this, Biggie? You get 2 times, yeah, you get this, right? 1 over x squared, but what do you have to multiply by? By not 2, 2x. The c goes away because the derivative of a constant is. So what does this equal? 4x over 1 plus x squared. So unfortunately, this right here, is that the right work? No, it's not. It's not. Okay, so I'm going to give you a big, massive hint on this. You ready for your big, massive hint? F prime of x is equal to 2 times 1 over 1 plus x squared. Does that help you at all? In particular, does this look familiar at all? I literally quizzed you for a week on this. I literally quizzed you for a week on that. That is the derivative of something you've seen many times. Inverse. Do it. Finish it. Inverse what? Inverse tangent. So what does this actually equal? What does f of x actually equal? 2 times? 2 times? Come on, kids. I just literally led you to the answer. Drink the water. Tan inverse of what? Of x plus c. Why do you know that's true? You know that's true because you've been told many. We did them out. Remember we did inverse trig derivatives when we were doing implicit differentiation? What is the derivative of tan inverse? This is not a hypothetical question. I'm asking you, what is the derivative of tan inverse? 1 over 1 plus x squared. So what's the general antiderivative of 1 over 1 plus x squared? Tan inverse of x. Exactly. Are you done yet, though? Is this done? No. Why isn't that done?
Because you have a point and you find the c value.
You have a general c value. You want to actually know what c is equal. So how do you find out what c is equal to? Well, you know that f of 0 is equal to what? 1. So 1 is equal to 2 tan inverse of 0 plus c. When is tangent equal to 0? When is tangent equal to 0? At what? When is tangent equal to 0? Come on. At 0. So you think 1 is equal to 2 times 0 plus c. So what does c equal? 1. So what's the final answer to this? F of x is equal to 2 tan inverse of x plus what? 1. There's your final answer. How do we start? To find the absolute maximum value of a function, what are we trying to find? Where the derivative is equal to 0, that would be really helpful. So what are we going to need to do to this function? Take the derivative. What's the derivative, Fawn? Minus 2t. So in order to find out where this is equal to 0, the reason that, why did I ask you to use Newton's method on this? Why are we resorting to using Newton's method?
Because the calculator would give us Newton's method.
If you had no calculator, let's say you had no calculator, and I asked you to solve this, what would you say? It's what? I don't understand. It is absolutely not nicely factorable. If I asked you to do this one by hand, you would say, okay, kids, stand up. This by hand right here, this right here, this question. Very hard to do by hand. Very hard to do by hand. So what are we going to do to find the 0? What are we going to use?
Calculator.
Specifically, what are we going to use? Newton's method. We're going to do what the question asks us to do, to use Newton's method to find the absolute maximum value. So we're going to use Newton's method right here. So if we're going to use Newton's method right here, what are we going to enter in for y1 on our calculator? We're going to enter in this function right here. That function is negative sine t plus 1. So y equals negative sine x. What was it? Plus 1?
Plus 1 minus 2x.
Minus 2x. And then what do we plug in for y2? Because we're trying to find we're trying to find out where this is equal to 0. So what do we? You don't need to use the calculator to do basic math. So tell me what I should use. Y negative cosine?
Because the derivative of sine is cosine.
And it's negative, correct? Minus what? 2. And then what do I plug in right here? X minus what? X minus what?
Y1 and y2.
Yeah, we've done this a bunch of times. Y1 divided by what? Y of x divided by?
Y2 of x.
Yeah, y2 of x, y bars function, y2 of x. Then we're going to go back to the main screen, and I said, what value should we start with? Oh, does it tell you the value to start with?
No.
So you have to make an initial guess. What's your initial guess?
It's a 1.
Say 1. Okay, so let's try 1. So if we try an initial guess of 1, it bounces to negative 1.84. So then what do I do instead? I do vars, y vars. Oh, is that y1? So it's y3 evaluated at 1. Good. And then what do? Vars, y vars. You do y3 again? Of answer, right? And now you just mash the enter button. And you want, I said, how many decimals do you want this to be accurate to?
8.
8. Second enter. Like this. Now, how many decimal places have stayed the same so far? 1, 2, 3, 4, 5, 6, 7, 8 of them have stayed the same, right? But we haven't plugged this into the output function, correct? What is the original function? So say that again. Cosine what? Cosine x minus what? Plus x minus what? X squared. So a great way we could do this, we could do the whole thing. It needs to run y3, right? So let's keep on running this. Let's run it one more time here, shall we? Second entry. And then I'm going to do, not y1, I'm going to do y. I entered it as y4. Do you see here? So I'm just going to do y4 of, oh, missed it. Vars, y vars, enter. Y4 of what? Second answer. And there we go. So if we wanted to check, so that's our initial, we think that that's the maximum value. We haven't done a couple things here which are really important. One, we haven't proven that that was a maximum. We'd have to use the second derivative test or the first derivative test. The other thing is it says make sure that this is accurate to how many decimal places? 8. Do we know necessarily if this is accurate to 8 decimal places? No, we need to do like the next one and see if 8 stay the same. It's a little challenging because what was our last one? 0.3354118. You see this last one right here? So we need to do y3 again. Let's do y3 again. y3. And what are we plugging in for that? Second answer, but not second answer, right? We need 0.33541. Is it really important that I type these correctly? Yeah. Oh, and then there should be a parenthesis there, right? Let's go back to the beginning. Yay. Second insert parenthesis. So this gives us our next x value. And now what do I do with that value? What do I do with this value? What function do I run? Run y4 to see what the output is. And hopefully not much has changed. We just did it again. How many decimals stayed the same? All of them stayed the same. So if all of them stayed the same, How many decimals are we accurate to? 1, 2, 3, 4, 5, 6, 7. Goes actually to 9 decimal places right there. So do we have our answer right here? Yes, we absolutely do. So we're in L'Hopital's rule, so it's a strong hint that you might have to use L'Hopital's rule. So give that a try. Try 10. Okay, on number 10, what do you have to check first?
If you can substitute.
If you can apply L'Hopital's rule. So you check, what's the limit as x goes to infinity of e to the 4x minus 1 minus 4x? What is that? Yeah, e to the 4x as x goes to infinity gets pretty big, right? And what's the limit as x goes to infinity of x squared? So which form do you have? Infinity over infinity. That is one of the indeterminate forms. So you are happy you can apply L'Hopital's rule. So remember the h with the equal sign? What's the derivative of the top? What's the derivative of the top? 4e to the 4x minus, and then what's the derivative of the bottom? Can you apply L'Hopital's rule? Yeah, it is infinity over infinity still, so you can apply it again, so you end up with, what? 16e to the all over 2. And you still have this limit going down this entire thing, right? So what's the limit as x goes to infinity of that? Yeah, it's still, the bottom is static, the top is huge. So it definitely is infinity. To say x squared is going to 0, right? As x goes to 0? Yay! What's the natural log of x going to as x goes to 0 from the right? Negative infinity, right? If you multiply 0 by negative infinity, what do you get? You don't know. They're doing battle with each other, right? One of them is trying to make it infinitely small, and the other one's trying to make it negative but infinitely big and negative. So the question is, which one's going to win? Is it going to be a stalemate, or is one going to win? Is it going to go to 0? Is it going to go to infinity? Is it going to go to 7? Can that happen? Yes, that definitely can happen. So we look at this and we say, we're in AP Calculus. We don't have that many ways to attack this, and I told you that L'Hopital's rule might come into play. So you want L'Hopital's rule to come into play. What do you have to do in order to see L'Hopital's rule come into play? Make it a fraction. So which one do we want to put on the denominator? You sure? Which one? You pick. 50-50 chance. How about this? Yeah, it is a 50-50 chance. You try it and then see if it works, okay? So let's put this x to the what? Negative 2. Do you agree with that? Yeah. Now, if L'Hopital's rule applies, we have to check. We have to check to see if L'Hopital's rule applies. So let's do that. What's the limit as x goes to 0 from the right of ln x? We already figured that out. What is it? Negative infinity. Because what does ln x look like? It spikes up from negative infinity. What's the limit as x goes to 0 from the right of x to the negative 2? What's another way to write x to the negative 2? 1 over what? So what's the limit as x goes to 0 from the right of that? So what do we end up with? We end up with negative infinity over infinity. Is that an indeterminate form?
Don't you have to bring the infinity to the answer when you're done?
The negative is what you're talking about. We've run into this before, and let's just keep that in mind. It's a very good thing to remember. We've run into this issue before, and it's taken care of itself. Remember how we like square it and it doesn't matter? Let's see what happens, okay? So let's take the derivative, and what do we get? Let's apply L'Hopital's rule because we can. What's the derivative of ln x? X to the negative 1. And what's the derivative of the bottom? Negative 2x to the negative 3. Oh, wonderful. Okay, so the question now is this still an indeterminate form? What do you think?
No.
Well, let's try it. What's the limit as x goes to infinity of 1 over x? That's the numerator. 0. What's the limit as x goes to infinity of negative 2 over x cubed? 0. So is it an indeterminate form? Yes, it's 0 over 0. What? Is this still an indeterminate form? So if you notice that's an indeterminate form, what might you do? You might, hold on, if you saw it's an indeterminate form, you might keep going, right?
Yeah.
But the point is, do we have to keep going?
No.
No, because what can we do, Biggie? Thank you. You can simplify. Excellent. So what does that become? Negative 1/2 x to the what? X to the what power? X to the 2, right?
Yeah.
So you're looking at the limit as x goes to 0 from the right of that. What's that going to be? 0. It's going to be 0. Excellent. So we were tempted, because it is 0 over 0, to do another L'Hopital's rule, but do we have to, Biggie?
No.
because we should always, always, always look to, similarly, we should always, always, always look to factor, just in general. Can you simplify? Can you factor? Can you simplify? Can you factor? Well, hold on. What I mean by this is if this is counted as one function, this is counted as another, you kind of see two limits, right? So what paths do you have to take at this moment? What would you have to do in order to apply L'Hopital's rule? You have two choices. You can either what?
Find a common denominator.
Why are you finding a common denominator?
So you have one function.
Common denominator allows you to do what?
Use L'Hopital's rule.
You're going in the wrong direction. Having a common denominator with fractions allows you to do what? Combine the fractions using the operation of addition or subtraction. Having a common denominator allows you to add fractions. That's what I want you to say. And the reason you want to add fractions is because you want to get it as one fraction so you can apply. So that's one choice. So let's try that one. Apply because everything is going to 0. Makes us happy. Yay! Now what can we do to the top and the bottom? Yay! We can take the derivative. What are we going to have to use on the top? No. To take the derivative of x ln x, what rule do we have to use? Product rule. The product rule. The derivative of the first times the second plus the first times the derivative of the second. What's the derivative of ln x? And then minus what? Minus what if we take the derivative of the rest? 1. Thank you, yeah. And what's the derivative down here going to be? What are we going to have to use on the bottom? Product rule. The derivative of the first times the second plus the first times the derivative of the second. What's the derivative of x minus 1? 1. Does L'Hopital's rule apply here? I think it does. What's the natural log of 1? 0. So this is 0 on top, this is 0. And what's 1 minus 1? What's 1 minus 1? 0. So what is this whole thing? 0 over. So does L'Hopital's rule apply? Yeah, sure. I don't really want to simplify it. I just want to keep on taking derivatives. Okay, now it's going to get a little bit more fun. We're applying L'Hopital's rule again. What's the derivative of the top?
1 over x.
Well, that's helpful, right? We like seeing 1 over x, right? Well, at least I do. Okay. And what does the bottom become? What do we have to use down there? Yeah, low d high minus high d low all over what?
Low squared.
Plus what?
1 over x.
1 over x. Exactly. Take a look at that. What's actually kind of nice about this?
That's really easy.
No more what is there? No more ln. Is that kind of nice?
Yeah.
Say yes. That's nice. So what should we do now? What should we really do now? Simplify. Let's simplify this sucker. So what do we end up with? We end up with 1 over x over, what do we need? You have x,
Plus 1 over x.
you have x minus, look what happened, x minus x plus 1 all over what? Plus 1 over x. So what does that become? 1 over x all over,
X plus 1 over x.
is that correct? Is that correct?
Yes.
So in order to add fractions, what do we need to do? What does that become? 1 over x all over 1 plus x over x squared. I needed a common denominator. Is everybody following me so far? What did I do here? I multiplied this by x over. Is that correct? So what does that become? 1 over x times what? X squared over 1 plus x. So that becomes x over what? 1 plus x. Is that pretty cool? So now, what do we think?
Yes.
What number is this?
13.
Woohoo! 13! We got it right! Everybody stand up. Stand up. 30-second like dance break. Come on. Biggie, you are forced to dance. Let's go. Patrick, let's go. Come on, dance. Do you want to do a different, like something else? Come on, Patrick, let's go. Come on. Patrick, let's go. Patrick, come on. Patrick, let's go. Patrick, come on. You gotta move your arms. Move your arms. There you go. Come on. Legs. Erica, come on. Let's go. Legs. You gotta move your legs and arms. Let's go. Let's go. Come on. Come on. Do you need some music instead?
Oh, it's
Yes.
okay.
It's okay?
Yeah, music.
You want some music? Okay, I'll be better prepared. Right now, since this is, remember I had to delete everything and reinstall everything, the only music I have on here is the one Nicole Westbrook song. That's all that's on there. I think I have the worst quotient of like bad to good music because I have no good music and an infinite amount of bad music in the form of that one song. Okay, sit down. That's kind of cool. Honestly, that's really cool. So what were some of the signs along the way that we were doing the right thing there? Along the way, what were some of the guidelines that said, okay, we're cruising through this, and what were some of the signs that said, okay, we're doing the right thing?
Getting really nicely simplified.
At the end, it nicely simplified. So that's a great last signpost. You actually got a nice answer. It would be kind of random if you did it all wrong and got a nice answer, because generally, if you make a mistake, what happens? You run into a brick wall, right? You're trucking along, and all of a sudden, it's like, find the zero of this. And you're like, no. And you get up and leave. What's another signpost? I already told you one of them. What is it?
Get rid of the
Yeah, it wasn't done, but all of a sudden you got rid of everything and you just had X's. Is it nice to just have X's?
yeah.
Yeah, that's really cool. This is a really great problem. I really like this one. This is great. Okay, so what did we say? When's the test going to be?
Next Tuesday.
Next Tuesday? Don't move. Don't move. Let's say you have to do... I'll put the homework in here. You guys can leave. You'll have homework in here.
I would.
What?
How many questions should you have for homework?
10.
1.
So 110 then?
Divide it by 100.
How about 15 questions? 15 sounds great.
No, one really big problem.
Multiples of 3. You're welcome. Annyeong! Everybody dance on the way out. You're forced to dance on the way out. Come on, Neil. Dance on the way out. Dance. Let's go. There you go. They're falling asleep. Can you imagine someone falling asleep if I'm talking in front of them? It's so sad, you know? And it's still recording.